Alright, hello and welcome to this short video tutorial on how to use Cramer's rule. Cramer's rule is a method used to solve systems of linear equations by using determinants. It's a very powerful tool that can help you find solutions to systems of linear equations in just a few simple steps. So let's get started here. So first we need to take a look at a system of linear equations in two variables. And I'll write it down. A1 sub x plus b1 y equals c1, and a2 sub x plus b2 sub y equals c2. So to use Cramer's rule to solve this system, we need to calculate four determinants: the determinant of the coefficient matrix, the determinant of the x matrix, and the determinant of the y matrix. And so let's call the determinant of the coefficient matrix D, and then you're going to get that by calculating the determinant of the matrix of coefficients. So that's A1, B1, A2, B2. And then find the determinant of the x matrix. We replace the x column in the coefficient matrix with the constant column or column vector. So dx equals C1, B1, C2, B2. It's really do like this, it's just C1, C2. And that's your column vector. And then to find the determinant of the y matrix, you replace the y column and the coefficient with the constant column. So that's dy equals x1, c1, c2, and c2. And then finally, to find the determinant of the constant matrix, replace the constant column, the coefficient matrix, with the x column. And that's just basically the same as the coefficient matrix. So it's kind of redundant, but oh well. So let's call determinant of the x matrix dx, y matrix dy. And then, so now we have that. We're just going to use Cramer's rule, find the values of x and y. Dx, d, and then y equals dy over d. And that's pretty much it. So to use an example with actual numbers, we could consider the following system of equations. That's, I'll just do 2x. I'll just do 2x plus 3y equals 7. Just separate that. And then 4x minus y equals 1. So as stated above, to use Cramer's rule to solve the system, we need to get the determinants of the coefficient matrix, the x matrix, y matrix, and the constant matrix, which is just the coefficient matrix. So yeah, so this is just basically, I know a lot of people get confused on how to find the matrix, but this is just 2, 3, 4, and negative 1. And then I'll do this, and I'll call this D. So to find the determinant of this, you just multiply the diagonals and then subtract. So D, that's 2, 1, minus 3 times 4. Oops, that's 4. And then determinant D is negative 14. And then dx, that's basically, column vector is 7, 1. And then dx, just place x column, column vector, so dx will be 7, 1, and 3, negative 1. And then determinant dx is just 7 times negative 1. Minus 3 times 1, which is just negative 10. And then dy equals, just place the y column this time, 2, 4, and 7, 1. And then same always, just 2 times 1 minus 7 times 4. And then say get dy, that's d, determinant of dy equals that, and like negative 26. And now you can use Cramer's rule to find the values of x and y. So apply Cramer's rule. So x equals dx over d. So x is just negative 10 over negative 14. And then simplify that, that's 2, 5 over 7. Simplest one, and then equation y is just y equals dy over d, which is just negative 26 over minus 14, which is just simplify 13 over 7. The fourth solution to these system equations is x equals 5 over 7 and y equals 13 over 7. So now to check our work, you can simply plug the x and y values back into the equation. So I'm going to do that right here. So just do equation all the way back here, which is 2r, is 2x plus 3y equals 7, so we divide that through. And the second equation is 4 times y, 1, divide that through also. So 2 times 5 over 7 plus 3 times 13 over 7 should equal 7. So you get, this is just 10 over 7, and then this is just 39 over 7, and then the same number is 39, and then 49 over 7, which is 7. So first equation is correct. So the value we found for x satisfies the first equation. And now for the second equation, it's just 4 times 5 over 7 minus 13 over 7 should equal 1. 4 times 5 over 7 is just 20 over 7. 19 over 7 minus 13 over 7 is just 7 over 7, and 1 over 7 minus 7 is just 1. So this equation is also true. So basically the value we found for x satisfies the second equation. So yeah, that's pretty much how to do Cramer's rule. As far as real life examples go, could use use right here. So this is the source I used. So basically, we can use Cramer's rule to solve for unknown current values in an electrical circuit. And using a technique called mesh analysis, we can apply KVL, aka Kirchhoff's voltage law, around a loop or a mesh in a circuit, and then we can use Cramer's rule to solve for the unknown currents in the mesh. So again, this is the source I used. Drawings aren't mine, but this is a good example. So consider this circuit right here, trying to find current through resistor 3, this one. So if you notice, there are like 3 like enclosed like loops where current flows. So it's I1 and then I2 and then I3 right here. So all I have to do is apply KVL around loop 1, and then this is the equation to do that right here, and then do around loop 2, and then equation here, do around loop 3, right here. And all you have to do is create a matrix using equations using the same formula right here. And it looks confusing at first. All you have to do is go back to the values you were given up here and apply them in there. So, and then these are the unknowns we're trying to solve for the mesh currents, and then apply the voltages in this. This is going to be your column vector 2. 0. So all you have to do is get determinants. So find the determinant of this. Basically your basically D, like the last problem that I did. So this is your coefficient matrix. So determinant of that is 2388, and then A1 basically replacing the column vector from X, Y, and Z. So this is for X. It's determinant of A1 is 3920, and then A2 replace it for Y. It's 2302, and then A3 replace it for Z. Whoops, that's 3330, and then finally apply Cramer's rules equations to solve for the mesh currents. I1 is determinant A1 over A is 1.642 amps, and I2 A2 over A, then 1.964 amps or 964 milliamps. And then I3, that's determinant B over A, that's 2330 over 2038, that's 1.34 amps. And then finally to get current flow through the resistor, what the following asks for, I'm just going to do subtract I2 from I1, so I3 is the current flow through the resistor, I1 is I2 is 1.62 amps minus 1.964 amps, that's 0.670 amps, and basically 670 milliamps, that's the current flow through the resistor in the circuit right here, equals 0.678 amps. And that's it. That's pretty much it with Cramer's rule. Here are my references. These are all good sources. It's not really that complicated. It looks complicated at first, but it's not really that complicated in the end. Yeah, thanks for watching my video. I hope you get a good understanding of how to use Cramer's rule. And those of you in 120A, I hope this helped you out. I don't know if it did or not. But yeah, anyway, thanks for watching. See ya.